Earth's magnetic field may change faster than we originally thought. This is what recent new research explains. From The Conversation, Associate Professor, University of Leeds, Christopher Davis writes, "The Earth's magnetic field, generated 3,000 kilometers below our feet in the liquid iron core, is crucially important to life on our planet. It extends well out into space, wrapping us in an electromagnetic blanket that shields the atmosphere and satellites from solar radiation and cosmic radiation, unlike, for example, what we have on Mars. From what astronomers are telling us, Mars has lost its magnetic shield and also most of its atmosphere, and it's still losing some of its atmosphere that's left. But going back to this, yet the magnetic field of our Earth is constantly changing in both its strength and direction, and has undergone some dramatic shifts in the past, and this includes enigmatic reversals of the magnetic poles, with the South Pole becoming the North Pole and vice versa. The long-standing question has been how fast the field can change. Our new study published in Nature Communications has uncovered some answers. Rapid changes of the magnetic field are of great interest because they represent the most extreme behavior of the ocean of molten iron in the liquid core. By tying the observed changes to core processes, we can learn important information about an otherwise inaccessible region of our planet. Historically, the fastest changes in Earth's magnetic field have been associated with reversals, which occur at irregular intervals a few times every million years. But we discovered field changes that are much faster and more recent than any of the data associated with actual reversals. Nowadays, satellites help monitor changes in the fields in both space and time, complemented by navigational records and ground-based observatories. And this information reveals that changes in the modern field are rather ponderous, around 1/10 of a degree every year. But while we know that the field has existed for at least 3.5 billion years, we don't know much about its behavior prior to 400 years ago. To track the ancient field, scientists analyzed the magnetism recorded by sediments, that is in rocks, also lava flows and human-made artifacts. That's because these materials contain microscopic magnetic grains that record the signature of Earth's field at the time they cooled, for lavas, for example, or were added to the landmass for sediments. Sediment records from central Italy around the time of the last polarity reversal, almost 800,000 years ago, suggest relatively rapid field changes reached 1 degree per year. Such measurements, though, are extremely challenging, with the results still being debated. For example, there are uncertainties in the process by which sediments acquire their magnetism. Improved measurements? Our research takes a different approach by using computer models based on the physics of the field generation process. This is combined with a recently published reconstruction of global variations in Earth's magnetic field spanning at least 100,000 years, based on a compilation of measurements from sediments, lavas, and artifacts. And this shows that changes in the direction of Earth's magnetic field reached rates that are up to 10 degrees per year, 10 times larger than the fastest currently reported variations. The fastest observed changes in the geomagnetic field direction occurred around 39,000 years ago, and this shift was associated with a locally weak field in a confined region just off the west coast of Central America. The event followed the global Lachamp excursion, a failed reversal of the Earth's magnetic field around 41,000 years ago, in which the magnetic poles briefly moved far from the geographic poles before returning. The fastest changes appear to be associated with local weakening of the magnetic field. Our model suggests this is caused by movement of patches of intense magnetic field across the surface of the liquid core. These patches are more prevalent at lower latitudes, suggesting that future researchers for rapid changes in direction should focus on these areas. Now, what is the impact on society, today's society? Changes in the magnetic field, such as reversals, probably don't pose a threat to life. Humans did manage to live through the dramatic Lachamp excursion, Today the threat is mainly down to our reliance on electronic infrastructure. Such space events such as geomagnetic storms arising from the interaction between the magnetic field and incoming solar radiation could disrupt satellite communications, GPS, and power grids, of course. This is troubling. The economic cost of the collapse of the U.S. power grid due to a space weather event has been estimated at around $1 trillion. The threat is serious enough for space weather to appear as a high priority on the UK National Risk Register. Space weather events tend to be more prevalent in regions where the magnetic field is weak, something we know can happen when the field is changing rapidly. Unfortunately, computer simulations suggest that directional changes arise after the field strength begins to weaken, meaning we cannot predict dips in field strength by just monitoring the field direction. Future work using more advanced simulations can shed more lights on this issue. Is another rapid change in the magnetic field on its way? This is very hard to answer. The fastest changes are also the rarest events. For example, the changes identified around the Le Champ excursions are over 2 times faster than any other changes occurring over the last 100,000 years. This makes it difficult for scientists to predict rapid changes. They are black swan events, quote unquote, that come as a surprise and have a big impact. One possible route forward is to use physics-based models of how the field behaves as part of the forecast. We still have a lot to learn about the speed limit of Earth's magnetic field. Rapid changes have not yet been directly observed during a polarity reversal, but they should be expected since the field is thought to become globally weak at these times. This is on The Conversation. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.